Round 3 of random LeetCode problem, under an hour. Let's run it. All right, start the timer and let's get started. Okay. Zero index integer nums consisting of 3 times n elements. Okay. And to remove any subsequence of elements. Subsequence. Okay, that's unordered. Pretty sure that means you can take subsequence. Let's say there's A, B, C. That means you can take A and C out. I'm pretty sure. So you take remove any subsequence of elements of size exactly n from nums. Okay, so yeah, let's say I'm removing A, or whatever. Yeah, removing A. The remaining two times n elements will be divided into 2 equal parts. So B and C. Well, yeah. First n elements belong to the first part. And first n elements belong to the first part, and their sum is sum first. Next elements belong to the second part, and their sum is sum second. The difference in sums of the 2 parts is known as sum first minus sum second. For example, sum first is 3, sum second is 2, difference is 1. 2, 3, negative 1, yep. And the minimum difference possible between sums of the 2 parts after removal of n elements. Okay. So we have this example right here, nums equals 3, 1, 2. I'll put 1 because I'll have a negative 1 because if you remove the 3, then left is 1, right is negative, left is 1, right is 2, so 1 minus 2 is negative 1. Right? Okay. And the fact that it says subsequence means non-contiguous elements. I'm sure an example will verify it. Containing 2 elements each, so yeah. If we remove nums 2 is equal to 5, which is 0, 1, 2. And nums 3 is equal to 8. Wait, that's continuous. Surely we have another example. There isn't. Oh, it continues. To the minimum reference, we should remove nums 1, 9, and nums 4. Yep, non-continuous. 0, 1, 2, 3, 4 is 1. Array becomes 7. The resultant array becomes 7, 5, 8, 3. Difference in the sum of 2 parts is 5 minus 8 plus 3 equals 1. So that is not possible. There's a difference smaller than 1. Okay, so n is 10 to the 5. Nums I is equal to 10 to the 5th. Okay. That's interesting. Alright. So the important things to keep note. Let's just take some notes, right? So you remove n elements, and then partition or rather than partition, just split it in half. Split down the middle, because that way we don't get any of the wrong ideas. Because obviously just left half is right half. Sum minimize. Sum left half minus sum right half. Right? Boom. Cool. Okay, so interesting. Okay. So my first thoughts are definitely divide and conquer related, solely because of the splitting in half thing. If I can identify, because my goal is, right? Goal. Right? I'm thinking purely greedily, but the goal is make the difference as small as possible, minimum difference. So minimize left side, maximize right side, right? Makes sense? So to do this, honestly, not even dividing car, I just want to split into two subarrays. So what I want to do is, actually, I don't want to split into two subarrays because if let's say I remove 9 and 5, okay, well, the way my example would do it, I was split into left half here, right half here, and then I was thinking maybe I can, since I want to minimize the left side, I just remove the big numbers from the left side. So remove 7 and 9. Or you only remove two elements. Yeah, two elements. So I remove 9, and then on this side I remove 1, which I guess is okay. No, that's technically the opposite optimal answer, but I can see a case where it fails, essentially, because these boundaries 3 and 3 may shift. So for example, if the optimal thing to do was to remove 9 and 5, let's say, then the left side wouldn't just be 7; it would be 7 and 8. So obviously you can't just directly split it and move from there. You have to somehow account for that. Um, hmm. Here's what I'm thinking. I could modify this. I'm currently thinking whether that's worth it, because if I'm modifying this right, I can make it so that you always remove 1 from both side, assuming there's not an assuming the number of elements you need to remove to get to n is more than 1. You remove 1 from both side, or rather, hmm. If you remove 1 from both side according to the rule I described, how does that account for shifting boundaries? It doesn't. Hmm. Interesting. Let's see, minimize left side, maximize right side. I could do this. I'm really wondering though. Let's say I minimize the left side. Let's write out a little example, I guess. Do that 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 3 times 3, so you have to remove 3 elements, right? Correct thing to do in this scenario is remove these 2. And then one of the 8. Oh. Yeah, then this 8. Because that way it would be 1, 3, 8. And then 8, 9, 10. Or any of the 8s, really. Yeah. And the 8s will cancel out, so it'd be 4 minus 19, which is boom. So, oh, I have an idea. Oh, I got an idea. Okay, great. So same general concept, minimize left side, maximize right side, but instead we use a 2-pointer technique. 2-pointer. Start from left, leftmost. I only have a vague idea. I don't have exact formula, but leftmost and rightmost. Pop the element that hurts. I'm just gonna say hurts because that's the whole, if it's a minimized left side, then you want to remove the biggest elements on the left side. But if it's on the right side, you want to remove the smallest element. So we're gonna call it hurts that side more. All right. How do you implement a skip though is the question. Because obviously you don't want to only put up the ones that are on the edges. I'm looking 2-pointer. I don't know where to go from it though. Let's think. Let's think for a little bit. Pointer here, pointer here. It says I want to remove the minimum values. Yeah, so without seeing all of these, there's no way to know whether 3 is a high, quote unquote, high value for the right side or a low value. Think. Not really sure how to go from here. I want to start coding, but I can't figure out the whole skipping maneuver. That's the problem. Maybe I could find the max for the left side. But then what does that even do? It's gonna just pop everything that's not the max. Think. What are the key elements? Order matters, right? But I can modify the elements such that they can form. I can selectively pick 2 n elements, right? So what I should be doing is identifying the n biggest elements and the n smallest elements. And then somehow trying to pick values such that keep the n biggest elements on the left side and n smallest elements on the right side. Or the other way around, sorry. How do I do that? So I iterate through. And give each number a placing, right, based off of their. I feel I may be overcomplicating this, but we're just gonna keep riffing. So I give each number a placing based off of its rank. Or yeah, let's just say I do that. Then if so if the placing is, if it's current placement versus its placing. Okay. The placement versus placing, I think, is important, because if you remove the elements with the biggest difference in their in their placing, that will benefit the third sum the most. This is, I can't exactly prove this if you ask me to. It's mostly off of low-key vibes, kind of intuition, but I want to see what this would result in, and I don't have much better. So that's what we're gonna do. Let's go. So nums is our list. We call this ordered is equal to sort list. Right, sorted list. Yeah. Or sorted nums. There we go. For, or rather, let's call it the index is equal to, there it is. The key would be the value. So ordered I, and then that would be the value would be I, obviously. For I in range len nums. Go. Okay, that's the indexer. So now num removed is equal to 0, while num removed recalculating all the differences may be annoying. I could use a difference array though. Yeah, a difference array would actually really help. Okay, we'll make a difference array. The difference array would have to start out as the indexer differences. Oh, it'd have to be a difference array on top of the indexer differences. Because, okay, let's say I remove a value. That's supposed to be at position 8 if I sort it left to right. Okay, I'm gonna leave this as a comment and then try to figure out my implementation right now, because I want to hammer this out before I actually start looking at that. Whole number removed is less than n. Remove worst element. Num remove plus plus. Boom. Okay. And then we do the sum calculations. Sum calculation. Nice. Okay, now let's hammer out this whole num removed nonsense. No, or sorry, remove worst element. Remove worst element. Okay. There we go. Okay. So let's first remember how order to sort it. This is going to be ascending order. The order that I want means minimize left side, maximize right side. That's ascending order. Ascending order, remove n middle elements. Right? This is the ideal order, if I could sort it and then remove it. Obviously we can't because we have to preserve it, the order, but so now every item is sorted like that. So everything's indexed properly. Now I'll consider the whole difference right thing. So given the number moved to 0, which one do I want to remove the most? It's going to be the one where indexer versus the actual index. Well, actually, let me build the whole, the actual, let me build this first to find the first element to remove. So that means for lm in nums, let's say worst diff is equal to 0 if absolute value of enumerate. Again, I'm getting the sense that I'm overcomplicating this, but it's the only idea I have right now. So I minus indexer I just want to comment some stuff. Initial creation of, it's called the placement array, or we'll just leave it. I don't know if it's going to be a list or an int or just a worst diff int right now, so let's see if that's dot dot dot. Absolute if indexer lm greater than worst diff equal to I. That's just showing the position of the one to remove. So do that for all of them, and then boom, we have all the diffs. Now, I could, given that all the initial worst diffs are created, could store this in a heap, but then I won't be able to take advantage of the whole difference array to find the next one. Because let's say, for this, right, let's say this worst diff is the middle value, then yeah, let's say the worst diff is the middle value, then all the values that are supposed to be to the right, or let's say for the nums array, all the values that are to the right of that value will shift down by 1. Right, and thus I've realized another problem with my approach, and that is that the n middle elements will mess up this whole supposed to be in this place calculation. This is very annoying. I think maybe instead of indexer being like a hash map, should somehow incorporate that in the creation of the difference array, because then I can dynamically like kind of delete elements while continuing to keep track of the whole difference. So say the difference, this worst diff, is the initial value of the difference array, right? Then I remove it. Or rather, I shouldn't be calling it difference array because I don't think summed up, but yeah, we'll call it the ideal placement array. Or, well, we'll call it the worst difference, the worst element array, whatever. Then, if I remove an element, I can make that placement 0. Right? Then everything, I don't know how to make sure everything to the right doesn't get immediately killed, because there's got to be a better way to do this. How do I subtract 1? And besides, I fear this is also n cubed. Is n cubed all right? No, it's to the 5th. So that means what, 10 to the 15? And I think this is in it under a second, so probably n squared. Or just n log n. Let's budget for n squared. I can't really find a solution right now. Okay. Let's go back to the basics. Take an array. Split it down the middle. I know before I said that was wrong, but we're going to forget about that for now. Split down the middle. And then the left side, find the max of it. Right side, find the min of it. Whichever one. Yeah, that's the problem, isn't it? Can't figure out which one's worse. Well, I guess I technically could, because in the whole max operation, I'm iterating through all the elements anyway. So I can also calculate the average. So calculate the average and find the max. Calculate the average, find the min. Remove whichever one's worse. Do that n times. And you have n squared. Wait, what? That can't be right. Should I be trying to brute force this? Okay. At the risk of, I mean, this isn't working anyway. Let's just brute force it. Why not? I should check the constraints for, like, I don't want to speak too soon. We'll see what happens. So, first thing is 4. Wait, let's create 2 defs. One will be the left iterator, and then it'll take in an array, and then return a tuple. I think that's how you, yeah, which would be an int being the average, or the worst, the max, and the float, and a float being the average. For lm in R, max is equal to what? The nums are, yeah, 1 to 10 to 5, so 0. And the sum is also 0. Sum plus equals lm if lm greater than max, max is equal to lm. Oh, I can't use max or sum. That's dumb. Maximum sum maximum. I'm essentially combining the max and sum functions just so I can get a little bit faster efficiency. I don't want to do O of n twice. Yep. Now sum is equal to sum divide, or I should write divide equals to, divide equal to len r. Go. And we return a tuple being max and sum. There we go. Left iterator is complete. The right iterator just wants the minimum. Minimum, which is what? Less than or equal to 10 to the 5th, so let's do 1e6. 1e7, why not? Minimum. 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 There we go. Now, for I in range. Yeah, how do I do this? So I want to run left iterator. So num taken, or num dropped, equal to 0. While num dropped is less than n, which is, I should actually do something to calculate n. Let's do yep, clear to me. So n, while num dropped is less than n, right? Should be called right iterator. Go left iterator r L equals len r, or len nums. I should be returning index so I know what to drop. Oh, I'm about to sneeze. All right. Given that I know the average, let's do return the maximum minus the sum, because that's essentially the problem, the difference, right? And the index, which is There we go. Quick few changes. Text is equal to I. Minimum. All right, so I comma diff is equal to j comma. All right, I should write ldiff rdiff is equal to that. All right. Bang. This might be one off, which may bug me, but I don't think so. Let's see what happens. And this also might be just not fast enough, so that would be a whole nother issue. But again, I don't want to deal with that. So nums dropped is equals 1. Nums dot pop. I don't know how to do the. I might be able to do the comprehensive conditional, whatever it's called. Nums I if, or if L diff greater than R diff, else nums dot pop j. This might be. I don't know how to do the one line conditionals. May work, may not. Worst case, I just expand it. It's fine. And then we just do sum. Of nums from 0 to n, right? I don't need the 0. N, so that'd be 0 to n minus 1, which is, yeah, n elements. We do sum of nums from n to the end, subtract them, we print this. That makes sense? Run it, see what happens, I guess. Line A. Oh, I might not use tuple here. Ugh, whatever. I think it might be brackets instead, but I don't want to. That was just for my own clarity, so that's fine. I use nums. Did I use that anywhere else? Should be fine. It's supposed to be minimum. Oh, maximum. Oh, maximium. Can't spell. Do the same thing. Minimium, yep. Did I spell wrong again? Num dropped. Oh my god. My biggest weakness isn't coding, it's spelling. Or my biggest weakness in LeetCode isn't the actual code, it's the spelling. Must be integers or none or have an index. Oh, right, it's not n. Wait, it is n. N is a number. That's interesting. I think it's worth it to print n here. I don't know why it's not. Oh, it must be integers. I need to cast it to an int. I know it's guaranteed to be int, but it'll show up as 0.0, so. More answer. That's interesting. Why is this the output? Oh, we're supposed to return it? Yeah, we're supposed to return it. That's not good. Whoops. Just gotta return. Switch this to a return, and then we're good. Return. Interesting. Output was 2. Okay, let's think about this one for a little bit. Well, I want to print nums before I actually start anything. I need debugging. Three and 1. Okay. So the problem is split in 2. Yeah, the odd is the problem. Okay, L would be what? Let's say n drop to 0. L would be 3. So divide that by 2, we get 1. So until 1, not including it. So it would be 3 on one side. And that'd be 1, 2 on the other side. The average is 1.5. Difference is 0.5. Difference is equal. We get the minimum element, right? Yeah, so we get the minimum element, so which would mean we get 1. Wait, standard out is 3, 1. Which is not right. Because 3 minus 1 is 2. Did I do this the wrong way? Minimize left side. Oh, yeah, I'm not doing that. I'm going to maximize right side. Why am I doing the exact opposite? Okay, so we're just going to quickly change these names. I fear it will still fail. So this guy we'll call the left iterator, which will give it the minimum. Yep. Interesting, why? -1. I'm getting -1 from, what is that, left iterator? Left iterator. Why are you -1, buddy? Oh, I see. Wait. Tell me no one was less than 1e7? Oh, I didn't do this. Okay, 0, 1. Now we're getting sensible outputs. I could debug this. I'm at a crossroads right now. I could debug this, yes. But also, what if my initial strategy was right? And I make a difference array, or I do the whole indexing thing, where it's supposed to be and where it's not supposed to be. I store the differences in the values, and then I remove the node with the item with the biggest difference. Still stuck on that. Like the biggest difference, given that it's in the incorrect side. But making that whole calculation, like defining incorrect side, and then what happens once I remove it, it just seems not correct. And this is just simulating the whole process. This may end up as a failure, unfortunately. I need to add a clause for if L is odd. Right, wait, okay. This even? Okay, let's consider the even case first before we go into odd. So 2, 0, 0, 1, 2, and 0. Oh, that's all right. Okay, I think it's supposed to be one of them supposed to be +1. So 7, 9, 5. That's correct. That's fine. Wait, so this would be 0, and then the length is 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So 0 to 3, so 0, 1, 2. 2 is fine. Oh, 0 is this. It's 8. Yeah, so you remove 5 and you remove 8. So 7, 9, 1, 3. What the? Oh, sorry. Yeah. So you remove 5. Why would you remove 5? No, you'd remove 8 because you want to maximize the right side. Why'd you remove 8? So you don't do absolute value. Where is it? Oh, is it supposed to be maximum? Yeah. So this is the average. Why was the average important again? Okay, maximum minus the average should be. Oh, the minimum, it doesn't make sense. It should be sum minus minimum, right? Oh, that is valid point. Not that I think this is gonna work. I do think this is a failure in the end, but I want to at least debug my solution, or I want to find it. I want to see where it fails, or how far I can push it really. There we go. Interesting. Still getting the same answers, which is annoying me. I don't think I'm solving this, unfortunately. But I want to know what went wrong. Let's see here. Run it. All right, please. There we go. Okay, 2, 0, 1, 2. And 0. The maximum. I'm finding the maximum on the right size. Wait, then why am I removing it? Oh, was the left in... I think I just tripped over myself. That's so annoying. Oh, there we go. Case 1 passed. Huh. Case 2 didn't. Let's see it. 0, 1, 2. 0, 1, 2. Oh, wait, it's 1. Yeah. 0, 1. 0, 1. Why am I removing a 9 here? Oh, yeah, we're trying to minimize it, right? Yeah. That makes sense. So which one did you end up removing? So with the greater absolute value, so the 1. So we have 79583. Right? So then 79583. It'll split it. It'll say 0, 1, 2, 3, 4. Wait, that's just 5. So 5 divided by 2 is 2.5, which would just be 2. So 0, 1, then 583. So 7 and 9, 8, yeah. So it picks 0 because 7 versus 8. So, wait, why does it pick 0? Shouldn't it pick 9 if they're equal? Wait, no, it does remove 9. It does pick 9, as evidenced by this. Or... wait, why is 1 still here? Whoa. Whoa, 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 what's happening? Okay, here now. I LDIF. 0, 1, Then 3, it starts at 3, so 0, 1, 2, 3, 0, 1. Right? And then since RDiff is bigger than JDiff, or LDiff, nums.popi should be happening. So it removes a 9. Why? Is it because my statement is wrong? This whole if statement thing? I will be quite mad at myself for trying something new then. No, it's not. Oh, I see. It was staring at me. R plus. I thought of it too while I was writing it. I just didn't voice it out loud, and thus I forgot. Right. -16 minus 13, just 3. 1. You get 1 by what? Nine and 1, which is, I don't know why I didn't remove 9. 1 is correctly removed though. And then 3 is removed. Oh, it should be the average of the whole array. That I should be comparing to. That might be true actually. That's a problem. Yeah, I believe that's actually true. I don't know why I was thinking like this. Well, that's unfortunate. Then we don't even need the iterators. Yeah. As unfortunate as it is, I do think I wasted most of my time now. Let's just find the min of the left side, or we want to minimize it, so we remove the max. And now we remove the min. Then LDiff minus equals, or let's get average. Average is equal to sum nums over len nums equal average. Still a lot of it. It's really annoying when you waste all that time doing useless code. Oh, that's 1 hour. Well, unfortunately, this was a fail.